Good morning, friends. Myself, Dr. R.C. Chauhan, Associate Professor, Samrat Prithviraj Chauhan, Government College, Ajmer. Today we will be discuss MSc Physics Semester 4th, Microwave Electronics, and that is the unit first. The topic for today is microwave tubes. Why we need microwave tubes? What are the applications of microwave tubes? How they are working? We will be discussed in this chapter. Let's start. We start with the introduction. At the microwave frequencies, the size of the device should be the smaller than the normal frequency, because here frequency is high. But for this, we should reduce size of the tank circuit, and tank circuit have the element LNC, inductor or the capacitor, because at the high frequency LNC should be the very small. So we need such type of instrument which have the, if you use the tank circuit, then that reduced to very smaller. But for the reduction, it is sufficient. There is a limit for it, so we cannot reduce for a smaller to a smaller size. So for this one, there is the shortcoming of this one. For this, we can reduce size of LNC up to the certain limit. And for high frequencies, many circuit parameters like are changes. Number one, the inter-electrode capacitance effect, because now the capacitance difference between the very small, so it will be the ineffective. C equal to epsilon naught A by D, so the D, the small c will be the very high. Similarly, the lead inductance effect, the inductance related with the leads of the wire, that is also this one. Transient time effect is a very important concept, and the gain bandwidth limitations effect due to the radiation losses. These are these 5 losses, 5 different parameters are there that are not suitable this normal tank circuit to produce micro frequency. So we need the special design tubes for such high frequency range, and these are known as microwave tubes. In the microwave tubes, we use transient time effect mostly, and for further, the basic principle of the operation of the microwave tubes involves the transfer of the power from a source of DC voltage source to the AC voltage. Means that is energy is transferred from one to other, and that is from a DC source to the AC source by means of a current density modulated electron beam. Means now this is the methods by which the energy will be transferred from the DC voltage source to the AC source, and that is the current density modulated electron beam. This is the basic principles of any device, micro device. This result is obtained by the accelerating electrons in the direct electric field and the retarding them in the accelerating alternating electric field. So we say we have to apply the electrons, the direct DC, and then retarding by the alternating electric field, and due to this retardation, they are delivering energy to the AC field. This is the method, this is the mechanism by which energy is transferred from the DC to AC source. On the basis of above methods, the microwave tubes are differ from each other tube. That is, we are using many vacuum tubes or the transistors like that devices. Now, what are the means? Their mechanism of the producing density modulations, the acceleration and retardation in the AC field, and retardation of the electrons by a short gap in general. So these are the 3 techniques by which we can develop a microwave tubes. In general, the process involves in the microwave tubes are the beam production, number 1, second is the velocity modulation, and third one the conversion of the density modulation, fourth one transfer of the energy, and that's last, that is the collection of the electrons. These are the steps to produce the micro frequency. Number 1, the beam modulation. So that is the beam production, electron beam production. Second is the velocity modulation. Velocity changes according to the signal, and then the conversion of the velocity modulation to the density modulation, and the transfer of energy from the DC to AC source, and the last, the collection of the electrons. The micro tubes are classified into the 2 basic categories. Number 1, O-type linear tubes, and the second one is the M-type tubes. In the O-linear type linear tubes, that is the TWT, traveling wave tubes, and the clustrons are there, and in M-type, that is magnetron and the cross wave devices are there. The main differences between the O-type and the M-type tubes is there. It will related with the two basic process or the facts. Number one, the energy conversion in the O type, that is the kinetic energy to the RF energy. Kinetic energy of the electron is converted to the RF energy, while in the M type tubes the energy conversion from the potential energy to the RF energy field. Second one, the role of magnetic field in the O type, that is only the focusing of the electron beam only, while in the M type the role of magnetic field is there. The magnetic and electric fields are perpendicular to each other, and the magnetic field plays the direct role in the RF interaction process. So this is the very important, that's why it is called the magnetic or magnetron or the magnetic electric tubes, microtubes. Now the first device is important basic instrument used in the microwave, that is the klystron. The klystron is a vacuum tube as a generator or a microwave amplifier at the micro frequencies. In this device, main electronics process are the velocity modulation by the RF field, as earlier we have write it. Second one is the conversion of the velocity modulation to the density modulation or the electron bunching. By electron bunching, this velocity modulation is changes to the density modulation, and then the transfer of the energy to the RF field, and last the collection of the electrons by the collector. Now the type of the klystron, microwave tubes, two cavity klystron amplifier, multi cavity klystron, two cavity klystron oscillator, and the reflex klystron. There are the four types of the klystron mostly we are using. Now we switch over to the first, that is two cavity klystrons. The two cavity klystrons are basically a velocity modulated tube. It consists of the cathode anode configurations, that is the electron gun, and to provide the accelerating electrons beam, that is the buncher I input cavity, catcher, that is output cavity, field free grid space between the input and output cavities, pair of the buncher grid first gap, pair of the catcher grid second gap, in the collector to collect the electrons beam. These are the basic devices. In addition to the above parts, there are some other are there: input coupling loop in the buncher input cavity, and the output coupling loop in the catcher, that is output cavity. Those whole assemblies in field in the vacuum analog with the vacuum sealed coaxial fitting for the external connections. Like this figure is there. Here, that is electron gun with the cathode is heated by the filament and produce the electrons and accelerated by the anodes. So that is electron gun. That is accelerating electrons are produced. Now that is anode is also used and the VG, and then that is go to the first plates, that is the buncher cavity, and here the RF input is there, and it will become the velocity modulation to the density modulation, and there are other different bunches are there, and then it is finally collected by the catcher cavity, catched by this one, and there is also this cavity is there. That's why it is two cavity system, and then it is finally collected by the collector. So here these are the distance scale and the time scale for this one. The distance between the two cavities is the L, capital L. Gap between the two grids is the D, so that is the 0 to D, L plus D to L plus 2D, and this is all about this one. Next time we will discuss the operation of it. Thank you very much.